See, in this question, you are able to see something in the domain and codomain. What is that they have put? You're able to see some special symbol. They have put an asterisk at the bottom. Like, what is the meaning of it? They have given it. No? You take all the non-zero numbers. Okay. So, meaning, what is the function given there? What is the function given? R star to R star. Okay. Where f, this is the function. This is how f and y are related. F of x is equal to 1 by x. Where clearly one thing you can say, x is not equal to 0 and x is positive also. That's what the meaning is, right? R star is a set of all non-zero real numbers. This is result true if the R star is replaced by a natural number with codomain being the same as R star. Meaning the second part of the question they are asking, if it was like this, does it still hold good is what they are asking. We'll come to that later. Oh, they told non-zero. Oh, sorry. Okay. So x is not 0, that's it. I'm sorry. Yeah, except 0, all the values you can take. I thought non-zero positive number, sorry. So that is obvious. Right. See, I have a question. If this was not given in the question also, will you be able to find it? Denominator cannot be 0. Because what kind of a function is this? These are all the minor points we need to concentrate on. F of x is equal to 1 by x. If I ask you to categorize this as a function and tell me what is the name you will give to this? It's a rational function. Why? It's a polynomial by polynomial. Is one a polynomial? 9th standard. Recollect. Is one a polynomial? No. Theriyadu. Good answer. Yes, it is a polynomial. It's called as a constant polynomial. Because 1 you can write it as 1 into x power 0. It's a constant polynomial. Right? So polynomial divided by what kind of a polynomial is this? It's a linear polynomial. So what should happen? What does the definition of a rational function tell you? Q of x should not be equal to 0. In this case, what is Q of x? X, no. X should not be equal to 0. So even if they didn't give this to you, you are supposed to find it. Purida, right? Now tell me, f of x is equal to 1 by x. Is this a 1-1 function? Simple, no? What are the steps we follow? x1 comma x2 belongs to R. Okay. So 1 by x1 will be equal to, which implies x1 is equal to x2. x1 would have not been equal to x2 when the value of x could have been 0. That is not possible because the domain itself doesn't have that value. So the other way of writing it is real number minus 0. You will see some notations like this also. I think you asked me yesterday, no? The r minus 7 by 5. Minus 7 by 5. Meaning of this is, from the real number set, you remove the element 0 alone. This is another way of writing. Am I clear with this? Okay. But can someone tell me how does the graph for this look like? Science student should know this, right? Thermodynamics. It's called a rectangular hyperbola. Okay, if you don't know, listen to this. You look something like this. This is how the graph will look. It's called as a rectangular hyperbola. For this, if you try to do the horizontal line test, is it passing or not? It will clear it. And you see, x equal to 0, it is in the downward direction, it is going to minus infinity, means this graph will never touch the y-axis. This part will never touch the y-axis. It's going to plus infinity or minus infinity. This another thing you can remember. Okay, so have this in your mind. What is the name of this? It's called rectangular hyperbola. Okay. Next, what about, so I think we proved the 1-1 function. What about an onto function? What about onto function? The same number of steps, no. Y is equal to 1 by x. What are we supposed to do? Rearrange. X will be equal to 1 by y. So what are you allowed to substitute? Look at the functions, domain and the codomain. For every non-zero real number that you substitute, you get a non-zero real number. Means for every element that belongs to the codomain set, there is a pre-image. That's it. Make sense? Right. So is the graph also helping you to understand whether it is onto or not? Let me see. X can never be 0. Y can also never be 0. So from the domain and the codomain set, 0 is removed. So are you getting all the real numbers? You are getting positive real numbers of y. You are getting the negative real numbers of y. All the real numbers are covered except 0. Hence it's an onto function. Okay. This is another way. Slowly understand it. Okay. This is not used for CBSE, but if you can understand this, you can master continuity and differentiability. Is this function still going to hold good for being a 1-1 and an onto function if the domain set is changed? So what was there here? Non-zero real numbers. Now it is changed to natural numbers, means all positive integers. Right? When you take the natural number set, is it going to be 1-1? No, don't get confused between 1-1 and onto. Your mind should work independently. 1-1 says that for every input that you give, the output should be unique. Means, where does the set start from? When you substitute 1, the output is 1. When you substitute 2, the output is half. When you substitute 3, the output is 1 by 3. Like this, for every natural number that you substitute, because what is the function? 1 by x? No. If I put n is equal to 1, f of 1 is 1, f of 2 is half, f of 3 is 1 by 3, f of 4, 1 by 4. All are real numbers. So you see the number will never get repeated. So every input has a unique output. It's a 1-1 function. But what about onto function? So for onto function, what are we supposed to do? X is equal to 1 by y. So now how is the function changing? F is mapped from n to. So if I take a real number and substitute it here, for example, tell me a real number which you substitute will make you fail to get a natural number. If you substitute 3 by 2 here, for example, if y is equal to 3 by 2, I am taking from this set. I put it here, what will I get x as? I will get 2 by 3, which is not a natural number. Hence, it's not an onto function. Check, I told you, they'll ask you like this also. Check the injectivity and the surjectivity of the following functions. Tell me. So going forward, you should do it in 2 steps. Right. So for the first one, f is mapped from n to n. F of x is x square. Right. So x1 comma x2 belongs to which set? Natural number set. What is f of x1? Sorry, f of x1 is equal to f of x2. So x1 square will be equal to x1 is equal to, but it is natural number only, It's a 1-1 function because you're taking only the natural, you don't take the minus into consideration. Why? Because the domain is natural numbers, So in this case, you don't write it as x1 is equal to plus or minus x2. Rather, you will write it as x1 is equal to x2. Meaning, here if you plot it on a graph sheet, right, how will you get? Will you get a continuous graph? Wherever natural number to natural number, obviously you will not have a continuous graph. You will only have dots, right? For example, if the question was like this, f is mapped from r plus to r plus, just for you to understand what I am trying to say, and f is mapped from r to r, like something over here. So you will draw this graph, this is the graph you are supposed to draw for this case. Whereas when they say r plus to r plus, it is only one side that you will draw, because r minus is ignored. Think what is happening. F is mapped from n to n. So you don't take the minus into consideration. X1 will be equal to x2. Hence, it is a 1-1 function. Okay, it is a 1-1 function. Then what about onto? Y is equal to x square. Right, then what will happen to x? X is equal to plus or minus square root of y. Okay. So in the place of y, what are you supposed to plug in? Natural number. And what is expected? Natural number. But is there a case where you substitute a value of y which will not give you a natural number? 2 itself will not give you, it's an irrational number. So there are certain elements in uh, the codomain set which do not have a pre-image associated in the domain set. So what kind of function is this? It's a 1 1. It is 1 1, but not onto. So injectivity is another name for 1 1. See, if you look at the first 3 questions, right, all the 3 are same functions, but what has changed? The domain and the codomain set. So tell me what will happen in the second case. Function is mapped from z to z. F of x is equal to x square. So is it a 1 1 function? It will not be a 1 1 function because you will have this step, till this step it is common. But what will you get? You will get x1 is equal to plus or minus x2 because integers can be negative also. Hence, it's not a 1 1 function. But then what about onto? Obviously, not onto, because when you talk about integers, you can substitute negative values also here. Negative value is obviously not going to give you a integer. Integer is also a subset of real numbers. Again, you will get the same thing. X1 is equal to plus or minus x2. What about onto? I think we have already proven in the example problem. No, it is not onto because you will get the same step. X is equal to plus or minus root y. In this y, what are you supposed to substitute? This real number. For every real number, will you get a real number output? No. Why? Because, for example, you substitute minus 2 here. You are not going to get a real number. You will get a complex number. How will you check the injectivity? So first you will take x1 comma x2. Where do they come from? In this question, they come from the natural number set. So you are considering 2 natural numbers. Then what are you supposed to assume? F of x1 is equal to f of x2. This is an assumption. In this, what will you what will you get? Very good. X1 cube is equal to x2 cube. When you take the cube root on both the sides, unlike the square root and the fourth root, you will not get plus or minus. You will only get either plus or either minus. So from this, what can you conclude? X1 is equal to x2. Hence, it's a 1 1 function. Then what about onto? For onto, what will you do? Can you tell me? Yeah. So first you'll write y is equal to x cube. Then what will you take on both the sides? Y power in the root. Which root? Cube root. Okay. So x will be equal to y power 1 by 3. So now you need to look at the domain and the codomain. F is mapped from R to R. Sorry, N to N. Natural number to natural number. So what are you supposed to substitute here? Natural number. Is there any, you are able to prove that there is a natural number whose cube root will not give you a natural number? We have. What is it? For example, you substitute 2. Cube root of 2 is not going to be a natural number. Alright. Hence it's not onto. It is 1 1 but not onto. What about the next case? What about the next case? F is mapped from z to z given by f of x is equal to x cube. It's a 1 1 function. Because you will again see the same step for cube root. X1 cube is equal to x2 cube, you will get x1 is equal to x2. Right? That is right. It's a 1 1 function. Y power 1 by 3, what will happen? In the place of y, you need to substitute integer and the output expected is a integer. You will not get, no. See, this greatest integer function I need to recollect. I mean, I need to remind you how this function works. It's also called as step of x. It looks like step on a graph sheet. Okay, there is a very important function because we'll discuss about this in 5th chapter also. So we'll see them in the next class. So tomorrow I'll do only, let's say, 4 to 5 problems. After that, I'll go to the inverse. So that in the weekend you can complete, you can sit and practice this chapter and come with doubts on Monday. By Monday, I want to wind up this chapter. Okay. And one more thing, if you see the app, right, there is another. I'm not sure how many of you went and saw the videos. In the videos, you have videos of this year, And I've also added pre-recorded videos for this chapter. See, those who are not able to, like, there is a confusion or something. I've broken down into chunks. Almost, I think 27 topics are there. I don't remember how many are there. But if you, whichever topic you want to see what is a transitive relation, you can go there. What is an equivalence relation? It is there. Like 5 to 10 minutes, I've completed the video. You can make use of that, right? If possible, go through inverse also and come, so that you will understand things better. Is the point clear? Right. So anything else? It's clear, no?